Hi, my name is Caleb Vines, and we're going to be covering changing bases and the determinants of matrices. Alright, so here we have the bases B1, or the base B1 and the base B2. They are represented with these vectors, and what we're going to do to solve this is set up a diagram over here to the left. And what we have over here is we're taking this, making it into a matrix. So anything that is in base 1, we can take into the standard base. And like, let's say we had a vector like 1, 2, we can multiply it by this matrix and it's going to be in the standard form. And then on the other side of the diagram, we have the exact same thing given from this information here. It's just another matrices that takes us from base 2 to the standard base. And we kind of run into a problem here. So with this, we want to go this way because we want to go from base 1 to base 2. But the problem is base 2 goes down to the standard base, which is against the current that we're trying to go. So what we need to do is in the formula invert it. So we get the identity matrix that will give us information that go from base 1 to base 2 right here. And then you'll also see the order is flipped. So whenever we go along one of these paths, we start from the right and go to the left, even though most things aren't like that. I know it's counterintuitive. But from here, it's just computation. So from here, we get the inverse of this matrix, which is this. We got a bunch of fractions, and then now we just multiply, and we get this down here. This is the identity matrix that will take us from B1 to B2. It's gonna go right past this, and with like let's say we plugged in a vector to this, like 1, 2, it would take us from B1 all the way to B2. It'd have to be in B1 though, or it wouldn't work. All right, now we're moving on to determinants. So we're gonna take the determinant of this matrix here, and then to take the determinant, if it is above a 2 by 2 matrix, what we wanna do is select a row or a column. And the easiest ones to do are ones like this here. So yeah. So we have 1, 0, 0, and 0. These three aren't going to do anything for this one. The only one we need to look at is 1. So whenever we do this, whenever we select this, we're selecting this column here. What we're going to do is What we're going to do is for each of these values, we're going to add this value, subtract this one, add this one, and subtract this one. Now for this problem, it's only going to be adding this one. And then now you're wondering, what am I referring to when I say 1? So you eliminate this column and this row because we selected this value. And then you take this 3 by 3 matrix and we end up with this right here. So all I did was take this 3 by 3 matrix and multiply it by this. If we wanted to do more, like if this wasn't 0, we would take this row, eliminate it, and then we have -2, 0, 0, 0, 3, 1, 1, 2, 0, multiplied whatever this value is. All right, but that's hypothetical. We'll actually get to do it on this next round. So over here we have another 3 by 3. We're not down to 2 by 2 just yet. So I'm going to select this column here because we got another 0. It's just going to make computation easier. But we have two values, 4 and 1. So for 4, we're going to do this here. So when we're back up here, we're going to cross out these two rows to get that 2 by 2 matrix, which you see here. And we're going to multiply it by 4. And then for 0, we're going to skip over it again. And we're going to get +1. Now we got a plus because, again, back to that array I showed earlier, we have plus, minus, plus. So we're going to add it, not subtract. And then whenever we cross those out, we're going to get this matrix here, another 2 by 2. And so we get 4 times this plus 1 times this. And from here, it's as simple as reducing it. And we're going to use this new 2 by 2 reduction function. So we have ABCD equals AD minus BC. And that's going to give us a straight numerical value. It will no longer be in matrix form. So here from simplifying, we get 4 and then AD, so 3, 0, minus BC, 2 times 1, is going to give us -8 for the first value, and then 10 for the second, and then that's going to give us a determinant of 2. All right, thank you for coming to my presentation. I use Symbolab and the lectures on Blackboard to get this information. Thank you for your time.